Hey, it's Benji Cole, son of Al Cole from CBS Radio and host of the syndicated talk show, People of Distinction. The talk that gives you an in-depth view of some of the most dynamic, intelligent, and successful people on the planet. Run to our website, alcoleenterprises.com for more info. Email me through benji@alcoleenterprises.com if you'd like to get involved with what we have going. And as always, please continue to like and follow our broadcasts. People of Distinction is internationally syndicated solely due to the love and support that you all continue to give. We're available across all major distributors, and as long as you keep following, we're going to continue to put out the content. Now sit back and strap in, because on the line with us today, we have the impressive Michael Albrow. And we're going to be discussing Michael's amazing book, Space Times Matter. 100 short stories about the universe. It's Amazon, it's Barnes & Noble, it is a whole host of other places. But make sure, check out his personal website, michaelalbrow.com. There, you're going to gather more information on him, on his book, hyperlinks set up to take you to the purchasing pages. Man, I'm telling you, it's a one-stop shop. Again, that's michaelalbrow.com. And I quickly want to take this opportunity and point out the fact that he was brought to us by Author Reputation Press. So for my writers out there who have gone through their process and now you find yourself at a crossroads because you need some assistance moving the book you just developed, head on over to authorreputationpress.com, because this is exactly what they specialize in. They're going to help you move all of your creative endeavors. And people, listen, it is an absolute pleasure to have Michael here on the line. Man, his book is something spectacular. You see it right there in the title, 100 short stories about the universe. There's no beating around the bush, man. His background is a physicist, but he breaks his book down into 100 bite-sized tales of cosmic wonder. Okay, his writing is going to be profound. It is inviting all of us to stand at the edge of the unknown. No PhD required, just curiosity. Sit back, strap in, get ready. This book is meant to be picked up, put down, revisited, and everything in between. And I promise you, when you purchase the copies, you start reading, you're going to understand why I say that, and you're going to do just that, all right? Let's strap in. Let's get it going here. Michael, first and foremost, welcome to People of Distinction, and thank you very much for being a guest with us. How are you doing today, sir?
I'm doing fine, thank you, and thank you for having me.
Of course. Michael, listen, man, we're looking forward to this. I would never be mistaken for a scientist, but I've always had some curiosity, man. So you not only offering your expertise, but doing it in a way that I think is going to be digestible to the everyday person, I think is key amongst all of this. And we're looking forward to discussing it. Let's talk more about your background so we understand that what you're discussing, man, it's coming from a knowledgeable place. Tell us a little bit more about yourself.
When I got interested in science, really as a kid, in astronomy, I used to go out and look at the night sky and made a little telescope and so on. So astronomy was my main hobby as a schoolboy. And then I decided to go to a physics degree, after which I just had to choose whether I'd go into astronomy as a career or subatomic particle physics. And I chose particle physics because then I could still enjoy astronomy. Everybody can enjoy astronomy by going out and looking at the night sky and a pair of binoculars and so on. You could see the Milky Way if you go to a nice dark site. But I could always enjoy astronomy, but by doing particle physics as a profession. But if I'd chosen astronomy as a profession, I might not have been able to do particle physics because that's something rather quite hard for amateurs to get involved in. That was the story. And then I went to university to physics and decided to do afterwards particle physics with a PhD at Manchester University. And after my PhD at Manchester, I was fortunate enough to get a position at CERN, which is a multinational laboratory in Geneva, Switzerland. And I had about 18 years there altogether, partly with CERN and partly with the Rutherford Laboratory in the UK, but they let me stay out in Geneva working on projects there. Then after a while there, I took up a chair at Stockholm University. The professor there was retiring, and I went there. And then that was short-lived because I was spending a lot of time commuting down to Geneva and where my wife could pick up a job again. So after that, I got a job over in the USA. I came to the USA in 91, a job at Fermilab, which is the main particle physics laboratory in the US with a 4-mile around accelerator, colliding protons and antiprotons. That was very exciting to get involved in that. So that's where I came, and I worked there. I'm still working there, even though I officially retired. I say officially because I'm still working. I'm just not getting paid for it anymore. That was about 8 years ago. That's my story there. And it's been a great ride so far, and it's still going on. I'm still working in particle physics while I'm doing writing and other things as well. That's a quick overview of my story.
Let's dive into this book, Space, Times, Matter. Tell us a little bit more about it so we know what to expect.
100 short stories about the universe, mostly about physics and astronomy. I call them stories, but they're not fiction. They're non-fiction. And there are 18 science poems at the back. You probably know the term flash fiction, where you're invited to write a fiction story in 400 words. And I call this flash non-fiction because each piece is limited to about 400 words. How it started was because after I officially retired, I wanted to do more writing, and I asked the editor of a local paper, monthly paper, if she would like a science column. And she already had a fashion column, an art column, and so on. And she said, I can give you a science column if you don't want paying for it. I said, I don't need paying for it. I just want to get it out there and get people interested in what's going on in science. So she let me do that, and that was going for 5 years, after which I had about 60 columns, and then I added some more from an exhibition I'd done with an artist friend, Shanti Chandrasekhar. She does amazing art inspired by science. She's Indian, and the art is abstract but beautiful, and we had a joint exhibition where 24 pieces of her art, and for each piece I wrote about the science behind her inspiration. That was at American University in D.C. a few years ago. We published a catalogue or book of those pieces, and since then we've had 3 more exhibitions of science and art, 2 at the Kennedy Center in D.C. and 1 at the Cosmos Club in D.C., and we're working on another one, which I hope will be put up by the National Academy of Sciences eventually when they get able to do more exhibitions. That's how the book came about. I had 100 pieces, and I contacted by a publisher called Fulton Books, who did a very good job with the book design. I like the book design that they did. And the cover is especially striking because that's a piece of art that I found it was used for a project review of particle physics in the USA. And I asked the artist, it's so appropriate, I asked the artist if I could use it, and I paid for that, and I think it makes a very nice cover for the book. So yeah. I'm really happy with the book design. It came out in February, so it seems to be doing quite well. I think it's what people like to have, because a lot of people interested in science, they want to know more things about the Big Bang or black holes or what they are, but they don't want to necessarily pick up and read a whole book. This is one they can just dip into, open it up at random if you like, read short pieces. So that is a different format, and I think it works pretty well, especially for people who just want to browse. And there's a whole section of beginning about science, pieces like science, non-science, and nonsense, which is hoping that people will understand the difference between science and non-science. By non-science, things like art and music and love and so on, and then science itself. And then nonsense is what is coming out a lot these days, unfortunately, and it's hard for people to distinguish between science and nonsense. And so I hope this will inspire people to think a bit about that. And maybe that's briefly an overview of the book, I think. So there you go.
Michael, I'm curious, throughout this writing process, how did you manage to balance simplicity with depth when explaining complex ideas like dark matter or even the quantum fields? Talk to us about that process and how you were able to take this and put it in a bite-sized form of, like you mentioned, 400 words or less.
Yeah, so I've always been very interested in telling people that I meet in the street or in a plane or something about science and doing it in simple terms. And so in this book, there's almost no equations. There are 1 or 2 pieces that do have equations in, and there are some pieces also that have some novel ideas about science that maybe would be interesting for even professional scientists to think about. But in general, most of them have no equations, and because I think equations put people off. Even a simple one like E is mc squared, they may have heard of that, but not really know what it means, or try and explain things like that. But always I enjoy telling people about science, and So when I started doing this, actually, I joined a writers group in my town of Naperville near Chicago, where I was living then. And we'd meet once a week, and people would share their writing, short stories, poems, or whatever. And none of them were scientists, but I could share my pieces, and they gave me good feedback. You can't explain that better, and so on. So after a year or so, I think I got pretty good at explaining these things, and hopefully anybody can understand them, including, by the way, interested kids, or kids of 10 years old, or even 8 years old. If they're science-minded, some of them are very smart, and they could enjoy it too. And it's not to so much teach them, but inspire them, and to know something about black holes. That's maybe enough that they want to know about it. But maybe they want to dig deeper. They can dig deeper. They can go to ChatGPT or the library, pick up books, and go deeper into it. But it's an introduction to these things, and I think anybody can enjoy.
People, you got to head on over to Amazon, Barnes & Noble, and a lot of other places. Most importantly, check out the personal website, michaelalbrow.com. Remember, the book is called Space Times Matter, 100 short stories about the universe. This is one you got to get your hands on. I'm telling you, it's going to be captivating. My follow-up question that I want to go into here now, Michael, something that I find very compelling and very unique is, okay, so we know the subject matter. We understand that it's broken up into 100 short stories. Interestingly enough, at the end of the book, the end of this collection, you have 18 science poems. Okay. Michael, walk us through this process here, man. Where does poetry, what made you blend poetry with physics? Where did that come from?
So at my writers group that I mentioned before, there were some poets, and one of the poets hosted a poetry soiree at her place once a month. We would gather around, about a dozen of us, and share poems. And I started writing poems at that time, and found that actually I had some sort of a talent for writing poems. Some of them, at first I thought poems everything had to rhyme and meters and so on and so forth, but actually poems are what you make them, and it's the way the writing is done. And I found that some poems actually do rhyme and meter and so on, but not all of them, but it's the way you put words into them. And so over the years, I built up a sort of collection of 18 poems. There are a few more I have, but I put 18 in the book, and they're mostly about science, but not all of them. At the very end of the book, you'll see one called a Thanksgiving poem, and another one is called Life Story, which is not so much science, but about whether, I say, you are the author, director, and the star of the story of your life. Will it be a novel, documentary, or a poem, or a winding path, or a happy ending, or a sad one? And a few verses there about life, and so they're nearly all science poems, but not all of them. And I enjoy writing poems, so that's it.
There you have it.
And that made it up to 100.
I love it. Listen, man, there's 100 in there. I'm curious to know, can you share one or two? And of course, not necessarily reading the stories for us or the poems, but just giving us a brief synopsis of one or two of them as a teaser so we know what to expect when we head on over and pick it up.
All right, just at random. So one section about astronomy, stories from the solar system or beyond. Twinkle, twinkle, little star, it's called. Because all of the kids learn a nursery rhyme or still song, Twinkle, twinkle, little star, how I wonder what you are.
Yeah.
So I talk about stars and how they work. And then the next one is, how does the sun work? How does the sun work? It provides us with the heat and light, but how does it actually work? So there's a little dig in there to explain how the energy comes from the sun. But in the first section, I talk about more general things like nature is the ultimate authority. That's an authority. You don't have to you shouldn't believe everything you read in black and white, because a lot of it is wrong. But nature can't be fooled. And some physicists have a brilliant idea about what the universe might be like, but it may be a beautiful idea, but if it's not consistent with the observations and facts, then they have to discard it. That's how science works. You have to discard. You have to be very humble in a way, because you have to discard ideas if they're shown to be not correct. There was one example I have of Fred Hoyle, who was an English astronomer and science fiction writer. I loved his science fiction when I was a kid, but he had this idea that the universe was in what's called a steady state, that it had infinite past, infinite future, no changes, And then he heard that apparently the universe was expanding. So he had to actually abandon that idea, although he was obviously didn't like to abandon it. It was a beautiful idea, but it wasn't consistent with the observations. Science works like that. And so many theorists now, we're puzzled about particles and how they get different masses and so on. And many theorists have ideas about what might be out there that we haven't discovered yet. There's dark matter, which astronomers tell us is holding galaxies together, and there's other evidence for a lot of matter out there in the universe, but we don't know what it's made of. We think it's probably made of particles we haven't discovered yet. But they've published all papers about possible ideas, but they can't all be right. In fact, most of them are probably wrong. But you have to explore ideas, and then experimenters have to look and see if they're right or wrong, and hopefully discover something. But frankly, a lot of the papers that I'm working on publishing with my colleagues are search for this, search for that. We didn't find them, but not finding them is not a failure. It means you found that something that's not there, and it's not there, and so you have to look elsewhere. So that's cutting out the crap, if you like, doing things that are, but by finding things that actually may be good ideas, but they don't hold up to reality.
Yeah.
So that's a bit how science works.
I love
some
that.
good pieces about that.
Michael, you also mention another thing that I find fascinating. The book also includes original ideas about space and time. Okay, in a similar fashion, can you tease one of these original ideas that maybe challenge conventional physics?
Yes, okay. There's one or two of these things. And one is about what's called dark energy. Now, we know the content of the universe, as astronomers and cosmologists tell us, only about 5% of all the stuff in the universe is what we actually know in the form of atoms and stars and planets and gas and dust and so on. Only about 5%. And then the rest is about 20% is called dark matter. And as I said, I mentioned before, cosmologists tell us it's there, astronomers tell us it's there, but we don't know what it is. We think it's particles not found yet. But then about 70% is called dark energy. And there's no real understanding of what that is. The story about Einstein, he developed a theory of the universe, and according to he believed that the universe was actually static and from infinite past to infinite future. Now, then Hubble came along and said, no, the universe is expanding. The galaxies are moving away faster and faster. And Einstein hit his head and said, damn, I could have predicted that. But instead, because he thought it was stable, he added a term to his equations called the cosmological constant. And then nowadays we found that actually something like that constant has to come in. But I say, if that is a field that fills the universe, that is really repelling space, pushing space apart, then what would that field be like? And one idea is that it's actually a field made of tachyons. Tachyons are hypothetical particles thought up when I started my research, actually, and they've not been found. We've looked for them. They always travel faster than the speed of light. And people say nothing goes faster than the speed of light. Einstein said nothing goes faster than the speed of light. But actually, no particles that have mass, like atoms and so on, or electrons that have mass, can go faster than the speed of light. In a vacuum, light goes at the speed of light. But these particles, if they exist, always travel faster than the speed of light. Because we haven't seen evidence for them, we know that they interact very weakly with normal matter, but they could exist. And they could exist, and if they do, they could be mutually repulsive and actually blowing the universe apart. So this idea, which is radical, if you like, not accepted, and I point out that it's not accepted yet, I say, maybe it will be, is that these tachyon particles exist, and they are responsible for dark energy, and there's a field. And then maybe they're just waves rather than particles, like radio waves rather than photons, particles of light. But so this is one radical idea. And another radical idea is about where's the antimatter in the universe? Because most people thought that when the universe started as with equal amounts of matter and antimatter, but we're all made of matter. What happened to the antimatter? And the general idea is that maybe there was a little asymmetry arose, and nearly all the antimatter annihilated with the matter, leaving only a little bit of matter left. Now, I have a different idea that actually the universe split at the very beginning, before the Big Bang even, into a universe and an anti-universe, where the antimatter is. So my cosmology idea is that, which I published a couple of years ago, actually, but it's that the antimatter is there in a parallel anti-universe, and we can't have access to it, but maybe in the very distant future, our universe and the anti-universe will merge together and close a sort of time loop. But the implication is that time of our lives, the psychological time that we know and love, and eggs don't unscramble themselves. You scramble an egg, it doesn't go backwards in time. But there's a different time than the time of electrons and photons and fundamental particles. They're two different times. These are radical ideas that I mentioned briefly in the book, saying that are not yet established science, but food for thought. And maybe they'll turn out to be right, but we'll see.
Michael, as we close out, man, my final question for you, what else would you like to tell us? Is there anything else you'd like to leave our listening audience with before we let you go?
Yes, well, one thing is I've always been very interested in science in schools. Back in 2005, which was the World Year of Physics, because Einstein's centenary of his discoveries about relativity and so on. So I said at Fermilab, where I was working, let's see if we can get out to 10,000 kids in their classes this year and give them science demonstrations about electricity, magnetism, or gravity and things like that. And we did that. And it went on from strength to strength. And partly because of that, and also because of my other writing, I was made a fellow of the American Physical Society for outreach and education. So that was good, and that was encouraging to me to actually do more outreach and get more involved in education. I never taught in schools. I taught at university, but at schools I was going out to schools and telling kids about science, about electricity, or about the universe, not to educate them, but just to inspire them and to get them to think, wow, this is cool, and maybe they can become scientists. And you don't have to be a super whiz mathematician to be a physicist. You can be handy building detectors, building things, be handy with your hands. There's many different ways of becoming an experimental physicist or astronomer, and I hope kids will get inspired to do this sort of thing. Maybe the book would be a very handy tool for school teachers to have in their desk. So if a kid asks them, please, miss, or please, sir, what's a black hole, they can just pull out that book and tell them something which could inspire them to dig deeper. So anyway, I just love talking to kids, and anybody who listens to me about the universe and particles and so on.
Man, listen, there needs to be a book 2, a book 3, a book 4. You just need to keep on coming with it, man, because there is a lot. And people, trust me when I tell you we barely scratched the surface. Michael's book is going to ignite your curiosity in the same way that it already has with mine. And a lot of you listening in right now, you're already heading on over there. So I'm going to re-impress it one last time. It's Amazon. It's michaelalbrow.com. Head on over there. Pick up copies of Space Times Matter today. This is one that you're absolutely going to be at the edge of your seat for and love getting involved with. You know where to go. Pick it up. Michael, this has been an absolute pleasure, man. Such an honor and a riveting conversation. Thank you once again for being a guest on People of Distinction.
Thank you very much for having me.